January 27, 1967. No launch. No countdown. No danger expected. 3 astronauts sat sealed inside the Apollo 1 capsule, for what NASA called a routine test. Then, without warning, a single spark turned the spacecraft into an oxygen-filled firestorm. 17 seconds later, 3 voices were gone. Apollo 1 never left the ground. But the mistakes made that night would change space exploration forever. January 27, 1967. Cape Kennedy, Florida. There was no launch scheduled. No rocket engines would ignite. No countdown clocks were running. Inside the Apollo 1 command module, 3 astronauts were strapped into their seats for what NASA considered a routine ground test. A simple systems check. Something they had done many times before. Virgil, Gus Grissom, Edward White, Roger Chaffee. All highly trained. All calm. All unaware that the capsule around them was about to turn deadly. At 6:31 p.m. a sudden spark flashed inside the spacecraft. Within moments, a fire erupted. In an environment filled with pure oxygen, the flames didn't spread slowly, they exploded. Over the radio, the last words were heard, "We've got a fire in the cockpit." In seconds, smoke filled the cabin. Temperatures rose beyond survivable limits. Pressure built inside the module, sealing the hatch tighter with every passing moment. Outside, engineers rushed toward the capsule, but thick smoke and unbearable heat made rescue impossible. 17 seconds after the first spark, all communication stopped. Apollo 1 never left the ground. But what happened that night would permanently change how humanity explores space. This is not just the story of a fire. It is the story of warnings ignored, pressure misunderstood, and a tragedy that reshaped NASA forever. To understand Apollo 1, you must understand the time in which it happened. The 1960s were defined by the Cold War. The United States and the Soviet Union were locked in a race not just for military power, but for prestige. Space had become the ultimate symbol of technological dominance. The Soviets had struck first. Sputnik. Yuri Gagarin. First satellite. First human in space. America was behind, and the pressure was immense. In 1961, President John F. Kennedy set an almost impossible goal, landing a man on the moon before the decade's end. This declaration pushed NASA into an era of rapid development, enormous budgets, and unrelenting deadlines. The Apollo program was born from this urgency. Apollo 1 was meant to be the first crewed mission of that program. Its purpose was simple: test the spacecraft in Earth orbit before attempting lunar missions. The ground test on January 27 was intended to simulate launch conditions without leaving the pad. But behind the scenes, compromises had been made. Schedules were tight. Contractors were under pressure. Design concerns were known, discussed, and sometimes postponed rather than fully resolved. NASA believed success required speed. Apollo 1 would prove that speed without safety comes at an unforgivable cost. Apollo 1 was not crewed by beginners. Gus Grissom was one of NASA's most experienced astronauts. He had flown 2 space missions and was widely respected for his honesty. He was also openly critical of the Apollo spacecraft, warning that it had serious flaws. Edward White was calm, disciplined, and brilliant. He became a national hero after completing the first American spacewalk. Within NASA, he was trusted and admired. Roger Chaffee was younger than his crewmates, but exceptionally skilled. Apollo 1 would have been his first spaceflight, the culmination of years of demanding training. Together, they formed a capable and professional crew. In the months leading up to the test, they voiced concerns about the capsule's wiring, communication problems, and large amounts of flammable material inside the cabin. Gus Grissom famously hung a lemon on the spacecraft during training to symbolize problems that had not been fixed. They trusted NASA, but they were uneasy. Still, when test day arrived, they climbed inside and sealed the hatch. They followed procedure. They did their job. None of them knew that the combination of pure oxygen, exposed wiring, and combustible materials had created a silent trap. Experience could not protect them. Skill could not save them. That night, even the best astronauts in the world were powerless against a deadly design. The January 27th test was called a plugs-out test. It simulated the final moments before launch, with the spacecraft running entirely on internal power. There were no engines firing, no fuel flowing, no expectation of danger. The biggest mistake lay in the atmosphere inside the capsule. NASA chose to fill the cabin with 100% pure oxygen at a pressure higher than normal air. This decision simplified engineering and reduced spacecraft weight, but it created an extreme fire hazard. In such an environment, materials that normally resist burning become highly flammable. Inside the Apollo 1 module were nylon straps, Velcro, plastic covers, and extensive wiring. Many cables were unprotected or poorly insulated. The crew had raised concerns about this clutter, but the urgency of the program pushed testing forward. Another critical flaw was the hatch. It opened inward and required several steps to remove. Under normal conditions, it took over 90 seconds to open. Under rising pressure, it became impossible. NASA engineers did not ignore safety intentionally. They underestimated risk. They believed that a ground test posed minimal danger. Apollo 1 showed that even on the ground, spaceflight systems can be unforgiving. At approximately 6:31 p.m. a spark ignited inside the Apollo 1 cabin. Investigators later concluded it likely came from damaged electrical wiring beneath Grissom's seat. In pure oxygen, the fire spread instantly. Flames raced across the cabin walls. Materials burned with explosive speed. Temperatures soared beyond 1,000 degrees Fahrenheit within seconds. The astronauts tried to respond. Chaffee's voice came through the radio, reporting the fire. Grissom attempted to open the hatch, but the rapidly increasing pressure sealed it shut. Outside the spacecraft, engineers ran toward the capsule. Dense smoke poured out. They struggled to breathe. The exterior metal grew dangerously hot. Without protective equipment, they could not reach the crew in time. Within 17 seconds, the astronauts lost consciousness from toxic smoke inhalation. Silence followed. By the time the hatch was finally forced open, the fire had already done its work. The capsule was badly damaged. The crew was gone. Apollo 1 proved that disasters do not always come with warnings or countdowns. Sometimes, they arrive during moments that feel routine, when vigilance is lowest and confidence is highest. Contrary to early assumptions, the Apollo 1 astronauts were not burned to death. Autopsies revealed that all three died from asphyxiation caused by toxic smoke and oxygen deprivation. The fire itself was fast, but the smoke was faster. The investigation identified a chain of failures. There was no single cause. Instead, several dangerous elements combined into a fatal scenario: exposed wiring, flammable materials, a pure oxygen environment, and a hatch that could not be opened quickly. NASA categorized the tragedy as a preventable accident. Public shock was intense. The nation expected miracles from NASA, but Apollo 1 revealed human error beneath the technological brilliance. For the first time, Americans saw the hidden cost of the space race. Exploration demanded sacrifice, but this loss felt unnecessary. NASA faced difficult questions. Why were known risks accepted? Why were concerns dismissed as manageable? Why did safety lose to speed? Apollo 1 forced honesty. And honesty would soon lead to radical change. Contrary to early assumptions, the Apollo 1 astronauts were not burned to death. Autopsies revealed that all three died from asphyxiation caused by toxic smoke and oxygen deprivation. The fire itself was fast, but the smoke was faster. The investigation identified a chain of failures. There was no single cause. Instead, several dangerous elements combined into a fatal scenario: exposed wiring, flammable materials, a pure oxygen environment, and a hatch that could not be opened quickly. NASA categorized the tragedy as a preventable accident. Public shock was intense. The nation expected miracles from NASA, but Apollo 1 revealed human error beneath the technological brilliance. For the first time, Americans saw the hidden cost of the space race. Exploration demanded sacrifice, but this loss felt unnecessary. NASA faced difficult questions. Why were known risks accepted? Why were concerns dismissed as manageable? Why did safety lose to speed? Apollo 1 forced honesty. And honesty would soon lead to radical change. Following the fire, NASA suspended all Apollo missions. The U.S. Congress launched formal hearings, demanding answers. Engineers, contractors, and managers were questioned in detail. The findings were damning. NASA's management culture had allowed schedule pressure to outweigh safety concerns. Communication failures between contractors and engineers were widespread. Design changes were approved without full risk analysis. For the first time in its history, NASA openly accepted responsibility. This moment marked a turning point. The agency realized that success in space did not come from bravery alone. It required humility, and a willingness to admit mistakes. Apollo 1 delayed the moon landing timeline, but it also gave NASA something far more valuable: clarity. The agency would either change, or continue making deadly compromises. NASA chose change. The Apollo spacecraft was completely redesigned. Pure oxygen was eliminated during ground tests. Flammable materials were replaced with fire-resistant alternatives. Wiring standards were rewritten. Circuit protection was upgraded. Most importantly, the hatch was redesigned to open outward in seconds. Astronauts could now escape quickly in an emergency. These changes added weight, cost, and complexity, but they saved lives. Every future Apollo mission carried the lessons of Apollo 1 inside its systems. When Apollo 11 landed on the moon in 1969, it did so on a spacecraft made safe by tragedy. The success of Apollo depended not only on engineering triumphs, but on remembering failure. Apollo 1 became NASA's foundation of safety, written in loss. Apollo 1 never flew in space. But its impact reached the moon. Gus Grissom, Ed White, and Roger Chaffee are remembered not for how they died, but for what was learned because of them. Their deaths forced NASA to confront its weaknesses. Their loss prevented countless future tragedies. Every astronaut who returned safely from Apollo missions owed something to the lessons of that fire. Space exploration is often celebrated through success. But progress is also built on failure, when those failures are acknowledged, studied, and never repeated. Apollo 1 stands as a reminder that technology without responsibility is dangerous, and ambition without caution can be deadly. Yet from tragedy came progress. The fire that should never have happened made sure others would survive. And that is the quiet legacy of Apollo 1.